Hello everyone, so let's start with today's session. So today we are going to discuss the remaining part of TOC. Okay everyone, so let's get started now. So let me check that if the screen is visible or not, and do let me know if I am audible. So yesterday we have completed the basics of TOC. Okay, and today the remaining part we are going to see, we also started with the regular language. So let's note some important points which will help you in the exam definitely. Okay, so let's get started everyone. So yesterday in the last class I was noting some points. Okay, so let's continue with that. Fifth point is subset of regular language may or may not be regular language. Okay, subset of regular language may or may not be regular language. The very famous example for this is a to the power n, b to the power n is subset of a, n, b, m. Okay, sixth is subset of non-regular language may be regular. Seventh point is regular language union DCFL is equals to DCFL. Okay, and regular language union CFL is equals to CFL. Regular language union SCSL is equals to SCSL. Regular language union REC is equals to REC. After that, regular language union RE is equals to RE. Okay, RL intersection DCFL is equals to DCFL. RL intersection CFL is equals to CFL. RL intersection CSL is equals to CSL. RL intersection REC is equals to REC, and RL intersection RE is equals to RE. Alright, so these are the properties which are very important, and definitely you should know all this. Okay, now let's see the next one. Eighth one, clean closure, which is denoted like this, and positive closure, which is plus of RL, is always regular language. Reverse of regular language is always regular language. 10th is every non-regular language has at least one regular language superset. Okay, which is universal language. Now 11th point is RL union L. So this is regular, and this L need not be regular. Okay, 12th is non-regular language union non-regular language, so which is L. Okay, which may or may not be regular language. So this can be may or may not be regular language. Alright, now let's note the 13th point. Regular language union L is non-regular language when this language is always non-regular. 14th is regular language intersection non-regular language. So this is regular language which may or may not be regular language. 15th is non-regular language intersection non-regular language is L, okay, which may or may not be regular language. The 16th is non-regular language intersection L is equals to regular language may or may not be regular language, which may or may not be regular language. Okay, so let's see now mathematical model of finite state machine. So I guess these points are very important, okay, and you now all know these points. Now let's see mathematical model of FSM. The very first is DFA plus infinite stack is DPDA. Okay, DPDA. And second is NFA plus infinite stack is equals to NPDA. Third is DFA plus finite stack is equals to DFA. Fourth is NFA plus finite stack is equals to NFA. Okay, and the power of NPDA is always greater than power of DPDA. Okay, so I hope there is no doubt in this. No doubts, everyone? Okay, now let's see the next one. Now let's see about Mealy and Moore machine. Okay. So Moore machine. So here output assembled with the state. Here the output is with the state, which is like this. And Mealy machine. The output is associated with transaction. So like this. So this is not A, this is like this. Now if we talk about the diagram, so of Moore, it will be like this. See, here Q0 output is there. Transactional states are there. Here 1 is there. Here 1 is there. Like this. Here 0 is there. Here 0 is there, here 0 is there, like this. Okay, so here it's like 0 1. Okay, w is equals to 1 1 0 0 n, and this output is equals to 0 1 0 0 0. Okay, n plus 1, right? So it's like this, and this is all of Moray. Now let's talk about Mealy. Mealy is like this: Q0, Q1, Q2. The transactions are like this. Okay, and it's like this. W is equals to 1 1 0 0 n, and the output is 1 0 0 0 n. Okay, it is like this, and these two machines are interconvertible. That means they can get converted into each other. So if you convert Moray to Mealy, then number change, then okay, not number, it's no change in number of states. Okay, no change in number of states. And if you talk about Mealy, so Mealy to Moray, then number of states may increase. Number of states may increase. So in Mealy machine, if Q is M and this symbol is N, then the number of states is M into M, max possible. Okay, so just writing. In Mealy machine, if states are M and symbols are N, the number of states in Moray is equals to M into N, which is max possible. Okay, now I hope this much is clear. Now let's see the grammar portion. Okay, let's just completely see the grammar portion now. I hope till here everything is clear. Now let's see the grammar portion. Grammar. So grammar is nothing but set of rules by which we represent a language. If there exists a language, then there exists a grammar for it. Language without grammar is not possible. So language without grammar is not possible. Okay, so important point is one language may have more than one valid grammar. Okay, Second is grammar without language is possible. Okay, is possible. After that, grammar can generate at most one language. Now, how the grammar looks like? It's like this. G is equals to V T S P. Okay, 4 tuple. V is variable. T is terminal. S is start variable, which is definitely unique. And P is production rule. P is production rule. So, okay everyone. So this is how the grammar is denoted. So this is how the grammar is denoted. Now let's see the derivation part of this. Derivations. The very first is to derive a string from the grammar. To derive the string from the grammar, what we do? LMD, okay, which is leftmost symbol resolved first. Second is RMD, which is rightmost symbol resolved first. Okay, then graphical representation, it will have parse tree, abstract syntax tree and derivation tree. So the point here we should note, if there exists LMD for a string, then will exist RMD for it and vice versa. Parse trees of LMD and RMD may not be same. Third is, we may have more than one LMD, RMD for a string. Fourth is, if n number of LMDs are possible, then exactly n RMDs are also possible. Okay. So this is clear. Now let's see ambiguous grammar. if there exist more than one LMD or RMD for any given string in the grammar, then it's ambiguous. So parse tree of LMD or RMD may be different, and grammar is ambiguous if we find at least one string for which more than LMD or RMD exist. Okay, and no algorithm exists to check ambiguity. That is why ambiguity is clearly undecidable. And there are some grammars from which we can remove ambiguity. Okay, and there are some grammars from which we can never remove ambiguity. And that never remove ambiguity is called as inherently ambiguous. Okay, so grammar is language ambiguous? If that is yes, so it is inherently ambiguous. If this is no, so can be converted. So this is G, this is language of G. So RE, REC, CSL, CFL, okay, DCFL, RL. So this is all unambiguous, and this is all may or may not be ambiguous. May or may not be ambiguous. Okay. Now let's discuss the type 3, which is regular grammar. Okay. Type 3 regular grammar. Left linear, right linear. Okay, left linear, right linear. So it's like V T star, okay, or V is deriving V, or V is deriving T star. Or, okay, now here left linear means V is deriving T star V, V is deriving V, V is deriving T star, like this. So at most one variable on the right hand side of the production should be there, and any regular grammar can be converted to an unambiguous grammar. Alright, now let's discuss type 2. Which is context free grammar, CFG. Okay, so it is V deriving V plus T star, and here V is any, like this. So single variable defines anything. Every regular language is CFG. You should note every regular grammar is CFG. Okay, and to check if two grammars are equivalent or not is undecidable, and to check two regular grammars are equivalent or not, so that is decidable. So you can note this point. Two grammars checking, it is undecidable, but two regular language checking, are they equivalent or not, so that is decidable. Okay, Now let's discuss type 1 and type 0. Type 1, context sensitive. Type 0, unrestricted grammar. Unrestricted grammar. Alright, so it will be alpha deriving beta, okay, and this alpha belongs to v plus t plus, and this beta belongs to v plus t plus, and this LHS is smaller than equals to RHS, okay, and this is restrictions, okay, here restrictions are there. Now here if you talk about, so alpha belongs to v plus t plus and beta belongs to v plus t star, and here no restrictions are there, no restrictions, okay. So Turing machine epsilon is not possible, so Turing machine for language this epsilon is not possible, okay, and context sensitive grammar does not produce epsilon, okay, it's like this. Now let's discuss Chomsky normal form, which is CNF, okay. So let's discuss now CNF. Chomsky normal form, the productions are of type V, V or V T. So T is terminal, V is variable, okay. In CNF, epsilon is not allowed, okay, and the algorithm for converting CFG to CNF, okay. So if you have to do this, then there are some steps. So the very first is remove epsilon production, which is useless inheritance. Second is remove unit production. Okay, remove unit production. Third is simplify the grammar. Simplify the grammar. A is remove useless variable. After that, B is remove unreachable variable. Unreachable variable. Okay, and the formula is number of steps in derivation. Number of steps in derivation is 2n minus 1. Alright, now let's see the next one. GNF. So GNF means production is in the form production of the form V T V star, where epsilon production not allowed in GNF. Okay, so exactly one terminal followed by any number of variables. So that is, an epsilon is allowed only in the start variable, and any grammar can be converted into GNF. So CFG can be converted into GNF. So if some of the point I am not noting but you feel that is important, you all can note. Okay. If length of string is n, then we need n steps for derivation from GNF. Okay, now let's see the concept of removal of, let's see the concept of removal of left recursion. So we cannot see that in detail because as this is a revision class, okay, so that thing you should be very clear. So if this is clear, so directly the questions will come, so you all will be able to solve them. Okay, I am repeating that again. So removal of left recursion, removal of epsilon production, removal of unit production, and simplification of grammar. This all if you know, then you will be able to solve some simple problems which will be asked. Okay, so let's get started with CFL now. CFL, okay, so CFL is more powerful than DCFL. Okay, DPDA is like into T, and this T is not actually T, it's a different symbol. It's like this, okay, looks like T but it's not. So Q into, we can perform push, we can perform pop, we can perform skip. The operations are like this. NPDA, Q into two to the power Q, push, pop, skip. Okay, so acceptance of PDA, this is by two methods. Okay, acceptance by PDA A is empty stack, B is final state. Okay, so by this it can get accepted. Now you should know that we can push more than one element at a time and also pop more than one element at a time. So this all you should know. And CFL union CFL is CFL, DCFL union CFL is also CFL. Okay, and DCFL union DCFL is CFL, and DCFL complement is DCFL, CFL complement is CSL. Okay, and CSL complement CSL may be CFL. Okay, may be CFL. and DCFL intersection DCFL is equals to CSL. Okay. Now let's see the set difference property. Set difference properties. So DCFL is CSL. R minus DCFL is DCFL. DCFL minus CFL is CSL. DCFL minus R is equals to DCFL, and CFL minus DCFL is equals to CFL, and CFL minus CFL is equals to CSL. Okay. By PDA, we cannot do more than one comparison. Okay. We cannot recognize non-linear power with PDA. Okay, and matching not possible. So non-reverse, but reverse matching is possible. So WW not CFL. Okay, but if you talk about reverse, so this is possible, is CFL. So this thing is possible. Okay. Now, and you should also be clear with the chart of closure properties. Okay, so make a chart of closure properties, and if you want me to provide it, so please comment it below for the chart of closure property. I will provide it to you, but for that you have to comment it below whether you want or not, or you already have that for revision. All right. Now let's talk about universal Turing machine. Okay. Universal Turing machine so it's a Turing machine where provided output itself is a Turing machine. Okay, and the set of all strings of the form accepted by universal Turing machine is also called as universal language. Okay, now what is countability and uncountability? Let's talk about it. So finite number of interval between two numbers item, so this is countable. Okay, R is equals to 0.12, 0.22, infinity. So this is uncountable. Such things are uncountable. But whole language, this is countable. This is countable. And you should note some points. Point number 1 is subset of countable set is always countable. Okay. Second is set of all Turing machines are countable. Set of all recursive unirables are countable, and union of two or more countable is always countable, and the power set of infinite countable set is uncountable. Okay, so power of uninfinite countable is uncountable, p is uncountable, so this is uncountable. 2 to the power, this is uncountable. Okay, so Cartesian product of two countable set is always countable. Complement of countable may or may not be countable, and complement of uncountable may or may not be countable, and intersection may or may not be countable. Okay, everyone. Okay, so let's continue next one. Now undecisibility also, just note it down, undecisibility. Okay, so here we have completed with the TOC. Now let's get started with CD, compiler design. Okay, compiler design. Okay, so let's discuss now compiler design, everyone. So definition is converting high level language to low level language. Okay, convert high level language to low level language. Okay, so this is the source, this is translation, and this is target. Any programming language, here also any programming language. Okay, so high level language can perform more than one operation in single statement, and low level language can perform at most one operation in a single statement. Now let's see the analysis and synthetic model of compiler, how it's like. Let's see this. So for that we have to draw a complete diagram. Source, so this is lexical analyzer. Okay, here is syntax analyzer, here is semantic analyzer, intermediate code generation. Okay, then code optimizer is also there, code optimization is also there, and after that code generation is also there, and the last is target. Okay, last is target. Now see, what is the analysis phase? So analysis phase is still intermediate, so till here analysis phase is there. Synthesis. Okay, and the complete so here this is for error handling. Okay, and here is symbol table. Symbol table. Okay, so it's like this. So there are total 6 phases of the compiler, as you can see. Now let's see one by one. Let's see lexical analyzer. So you can tell me if you have any doubt till here, everyone. Any doubt till now? The first is lexical analyzer. So lexical analyzer means program of DFA checks for spelling mistake of program. Okay, and divide source into stream of token. So I am writing this point, divide source code into stream of tokens. Okay, second is syntax analyzer. Syntax analyzer, So it's check the grammar errors of the program. Okay, so checks grammatical errors of the program parser. Okay, so it's like parser is a DPDA. Parser is a DPDA. Okay, the third is semantic analyzer. So semantic analyzer means checks for meaning of the program. Okay, so example, type mismatch, stack overflow. Alright, so with error handler, compiler can still work. Okay, now let's see the fifth point. So third one. Now this is the fourth one. Intermediate code generation. So this phase makes the work of next two phases much easier. Okay, and it enhances portability and reducibility. Okay, fifth one is code optimization. Loop invariant construct. Second is common sub experiment elimination. Third is strength reduction. Fourth is function inlining. And fifth is dead code elimination. Okay, so let's see the next one. Symbol table. So symbol table means data about data. Symbol table means data about data, which is metadata, right? And data structure used by compiler, and shared by all the phase. So without symbol table, compiler cannot work. Okay, it cannot work. It cannot work, right everyone? I hope there is no doubt till here. So let's talk about grammars in compiler design now. Okay, so And this, see, I have taken mix of TOC. Like first I have taken TOC because ideally you should understand TOC, and after that CD comes. And I'm taking in mixed classes, okay? Why? Because see, CD and TOC are like one subject, you can say. Okay? Not one subject, but they combinedly get asked sometimes. So that is why I've taken like that. And it's and if you will do this subject, again I'm saying 10 marks, nowhere is gone. Okay? And I've taken CD, Algo, C programming. So 18 to 20 marks are for that. And if you prepare aptitude, 15 marks. So calculate how many marks you can get. So 45 marks. Okay? BIGO 45. You easily can get. So this is BIGO of 45. 45 easily you can get if you just prepare this 3. Okay? So that is why the higher weighted subject of revision I am taking first, so that it will be beneficial for you all. Right? So TOC, grammar is left. So grammar is left in TOC, not TOC, CD, compiler design, grammar is left. After that syntax analysis phase is left. Okay, then we will see what is first and follow, some part of this. After that, some hierarchy of parsers we will check. Then bottom up parsers, completely we are going to study about that. And lexical analysis, syntax, directed transactions, and many more. Intermediate representation is also there. Code optimization is also there. Okay, so till here we are going to study. I don't know that whether it is going to cover tomorrow also, the compiler design tomorrow also whether it's going to cover or not, but surely we will cover the whole. And if you just do these 3 subjects, so 45 marks are nowhere gone. Okay, and the additional, now you can comment that after TOC CD which subject you want the revision of. Okay, I'll take that, or else I will go according to the higher weightage marks sequence, so that you can get easily marks on that subject. Okay, so okay everyone, I hope there is absolutely no doubt in today's class. And if it's there, you just can ask me, or you just can ask me some general doubts, preparation doubts question if you have any. Okay, so no doubts everyone. You can check the other lives also if you find them useful. Okay, so thank you so much everyone. See you all in the next class.